Hello everyone, my name is Samara Seda and this is my final presentation for the Engineering Management course. My project is titled The Feasibility of Installing a Green Roof System as a Measure to Mitigate Large Water Runoff. During this presentation, I will be covering the following topics. A review at the problem statement, including the objectives and the methodology. A look at the activity schedule and timeline. The importance of stormwater management and runoff analysis, the roof load capacity analysis, the proposed design, the cost analysis, and the closing statement. My project is located on a public institution in the west side of Puerto Rico, and it would be referred to as XYZ. This institution has been presenting flooding issues around its campus, especially on its parking lots. With the increase of civil infrastructure has created many impervious surfaces that generate a problem every time there are heavy rainfall events. Where XYZ is located is considered as a dense urban area, and this is an important fact for the analysis of this problem. The objectives of this project were to determine the physical feasibility or structural feasibility of locating the green roof system on top of the existing structure, and to determine if it is economically feasible to implement this system. The methodology that was followed was to determine the impact that the impervious surfaces have on this area, to study the water runoff, the load capacity, and to perform the economic analysis. The activities and schedule that were followed are shown on this slide. Every activity was completed successfully. There was a little bit of a delay in the runoff analysis, but this did not affect the completion of the rest of the activities. On this slide, the project timeline is shown, and as it can be seen that we are actually at the end of the project right now. As mentioned previously, impervious surfaces create a problem not only at XYZ, but this is a problem seen even island-wide and worldwide, with the construction of new roads, buildings, etc. Surfaces become impervious, meaning that water cannot infiltrate through it, and this creates flooding issues. It is important that institutions start taking part on this problem and managing the water that their structure is generating. There are many ways of addressing this problem. However, in this case, only the green roof and the rainwater harvesting systems were considered. When a system of this type are implemented, what happens is that a delay in the water runoff is created when compared to a bare roof. This is shown on this graph. A time gap between the peak runoff is created, and this happens because the water is being retained by the system. As I already mentioned, the green roof and the rainwater harvesting systems were the only ones considered. A green roof is a green space that is created by adding layers of growing medium and soil in order to absorb, retain, and reduce stormwater runoff. It has many benefits, such as noise reduction, temperature moderation. It could be used as a recreational space, and it could be used to grow plants that could be reselled, um, among other things. There are two types of green roof systems, the extensive and the intensive. Intensive green roof systems require a bigger structure because they are intended to be like roof gardens and a recreational space, whereas extensive green roof systems are only for the purpose of retaining water, and which was the type of green roof system considered in this project. A rainwater harvesting system is just a system that collects rainwater and stores it for later use. During this project, certain field visits were conducted to the site. These pictures were taken on the first field visit where visual inspections were conducted and measurements of the area were taken to generate this layout that was used to calculate certain things later on. The National Oceanic Atmospheric Administration has a tool called the Atlas 14 that offers a lot of precipitation information for different areas. And where XYZ is located, rainfall events from about an hour to 3 hours are very likely to occur. So therefore, the analysis was based on a yearly reoccurrence, and the arrow is supposed to point at the precipitation that will be generated. It's a little difficult to see from this graph, but the Atlas 14 also offers the tabular method, and for a 2-hour event, it would represent 2.62 inches of rain. A second field visit was conducted during a rainy day to measure the water retention and to be able to see how the roof was draining. And it was determined that 105.6 gallons could be collected per hour. And this was not very heavy rainfall, so maybe during September, October, a lot more water could be catched. This was based on a 50% catch of water. Based on this, the rainwater harvesting system could be used for irrigation purposes. Therefore, the rainwater harvesting system is being proposed would use a tank, a 1,000-gallon tank that would cost $559 plus tax and shipping and handling from plasticmart.com. The roof load capacity was carried out, and the parameter used to determine if it would be feasible or not to locate the green roof was the deflection. The deflection was calculated in two ways: the maximum deflection with the roof as is, and the deflection with the weight of the green roof. The maximum deflection formula is shown there, and the value obtained was 1.43 inches for a slab of 21.5 foot. The deflection normal to the slab would be the deflection caused by the green roof, and it turned out to be 0.0056 inches, which is smaller than the maximum deflection. And the constraint is that if the maximum deflection is bigger than the deflection caused by the green roof, then it is okay to locate the green roof because the weight would be sustained. Therefore, the proposed design consists of an extensive green roof with a soil mix of 2 inches. There are different types of soils that could be used depending on the type of plant chosen. It would use a 2-inch granular drainage media, protection fabric of 1/4 of an inch, separation fabric of 1/8 of an inch. The type of separation fabric would be polypropylene, and it would have a total nominal thickness of 4 inches. There is a local company that is called ASA Roofing Technology. They do green roofs, and their prices vary from $6 to $12 per square foot, depending on the materials and the procedure used. Therefore, for the cost analysis, the average would be used, so $9 would be the number to use. The plant chosen for this project was the Sansevieria trifasciata, also known as golden honey, and locally known as lengua de vaca. The characteristics are shown in this table. It has a typical height and width of 5 inches, has full sunlight requirements, it's dry tolerant. The soil required is sandy soil, has low maintenance, and a weekly irrigation frequency. The growth speed is slow, but they do tend to propagate a lot. Therefore, given the dimensions of the area that is going to be covered and the roof, I estimated that they could be planted 2 feet apart, and that would mean that 963 plants would be needed. They are sold in a local nursery in Cayey from $1 to $2 depending on the size, so $150 would be the number to use for the calculations of costs. So the total cost of this project is the cost of the green roof plus the plants plus the tank. The green roof would cost $34,776. The plants would cost $1,449, and the tank would cost $759. Plus tax, it will give around $41,000. This is the proposed layout that was generated with Google SketchUp. And this is a little animated version. So, for the closing statements, this green roof system would need maintenance. So there are different options that the institution could consider, such as wage labor, or it could be part of a class or laboratory or investigation. So students can participate, and therefore the cost could be minimal for the institution. Looking into the future, the roof could generate money if the plants would be sold. Obviously, they're going to propagate, so eventually they will need to be pulled out, so they could be sold or transferred into pots. The institution can consider expanding the green roof area to other parts of the roof, and see if it helps even more to reduce the stormwater. And it could also analyze the feasibility of turning it into a roof garden and recreational space. So the implementation of the roof is structurally feasible. However, the budget of the institution is very limited. So the only way that it will be feasible to construct it is if there will be external sponsorship. So thank you for watching. This is all for today. If you have any questions, please let me know.